Hi everyone, I am very much delighted to be here today to explain you about today's topic, that is linear differential equations of second and higher order. So in that I have chosen the topic that is particular integral method 6. If you follow my previous videos, that is method 1, 2, 3, 4 and 5, it will be very easy to understand. So I request you to follow those videos also. In this, if you see, the question is of the form f of d of y is equal to x bar m into v. If m is equal to 1, so this is how the question will be. F of d of y is equal to x bar 1 into v. For this, there is a formula to find the particular integral. So here see, the particular integral of 1 by f of d x into v is equal to x minus f dash of d by f of d into 1 by f of d into v. So this is how, using this formula, I will solve problems when m is equal to 1, x bar 1 into v. For this kind of problems, I will use this formula. Whereas if m is equal to 2, we have to go to method 5, particular integral method 5. So if you see the questions, there are some examples I have given. That is, if you see equation d square plus 2d plus 1 of y is equal to x into cos x. Here there is m is equal to 1. And if you see d square plus 9 of y is equal to x bar 1 into sin 2x. If you watch the question carefully, you can immediately identify whether it is method 1, 2, 3 or 5. Because in method 1, the question is of the form e bar x, single e bar ax. In method 2, it is sin bx or cos bx. In method 3, it is an algebraic function. It is of the form x bar k. In method 4, it is of the combination of e bar ax into some v. In method 5, it is of x bar m into v. And in the sixth method, it is x bar 1 into v. So this is how we have to select whether it is method 1, 2 or 3. Depending upon the question, we can immediately choose. So it is bar 1. So we have to solve the particular integral using this formula. So I'll show how to solve. Here is a problem for you. I would like to illustrate this point by solving the problem. So what is this problem? D square plus 2d plus 1 of y is equal to x cos x. So if you see this, it is clearly x bar 1. So what we have to do? We have to immediately go to method 6. Using the formula, we can derive. So before solving this, we have to find the complementary factor. How to find a complementary factor? So again, I have to take an auxiliary equation. See here, the auxiliary equation is f of m is equal to 0. If you see auxiliary equation, f of m is equal to 0. So instead of d, I have to write m, that is m square plus 2m plus 1 is equal to 0. For that, what I will do, this is of the form a square plus 2ab plus b square. So I can write as m plus 1 whole square is equal to 0. So m plus 1 into m plus 1 is equal to 0. So m plus 1 is equal to 0 and m plus 1 is equal to 0. Here m is equal to minus 1 and here m is equal to minus 1. Therefore, I can write the complementary factor as a c1 plus a c2x into e bar minus x. So this is how I got the complementary factor, c1 plus c2x into e bar minus x. Then how to find the complementary factor, particular integral? So yp is equal to 1 by f of d into xv. This is the question form. yp is equal to 1 by, what is f of d here? F of d is nothing but d square plus 2d plus 1. Here d square plus 2d plus 1 into, what is v here? Cos x. I'll write x into cos x. X into cos x. So I have a formula to find this, that is x minus f dash of d by f of d into 1 by f of d into cos x. What is f of d? D square plus 2d plus 1. So yp is equal to x minus, here f of d is nothing but d square plus 2d plus 1. What is the derivative of this? For d square it is 2d and for d it is 1. So again it is 1 by f of d, that is d square plus 2d plus 1 into cos x. Into cos x. Now, so this is method 2. So in place of d square I have to write minus b square. So d square is equal to minus b square. What is minus b square? The quotient of x is b, therefore it is minus 1. In place of d square I will place minus 1. So yp is equal to x minus 2d plus 2 by d square plus 2d plus 1 into 1 by minus 1 plus 2d plus 1 into cos x. So in place of d square I have substituted minus 1. Minus 1 and plus 1 got cancelled. So here yp is equal to x minus 2d plus 1 by d square plus 2d plus 1 into 1 by 2d into cos x. So I told you once, if the d is in numerator, you have to derive the function, and if the d is in the denominator, if d is in the numerator, you have to derive. If d is in the denominator, we have to integrate this. So this is x minus 2d plus 2 by d square plus 2d plus 1 into 1 by 2 times of, what is integration of cos x? It is sin x. So it is sin x. I will multiply and show you how to solve this. Yp is equal to, if I multiply this will be x by 2 sin x minus 2d plus 2 by d square plus 2d plus 1 into half times of sin x. Into half times of sin x. So yp, if you see this yp, I have to solve this one. Yp is equal to, so yp is equal to x by 2 sin x, and again here d square is there. D square, in place of d square I have to write minus b square, minus 2d plus 2 by minus 1 plus 2d plus 1 into half times of sin x. Minus 1 and plus 1 got cancelled. So yp is equal to x by 2 sin x minus 2, if I take common, it is d plus 1 by 2d into sin x by 2. 2 got cancelled. So yp is equal to x by 2 sin x minus, here it is d plus 1 by 2d into sin x. If you see, the derivative I have to get. So d square. So yp is equal to x by 2 sin x minus d plus 1 by 2. Here it is integration. Integration of sin x is minus cos x. Then yp is equal to x by 2 sin x minus of minus plus half times of d plus 1 into cos x. Then yp is equal to x by 2 sin x plus half times of derivative of cos x plus 1 into cos x. So this is derivative of cos x plus 1 into cos x. Therefore, yp is equal to x by 2 sin x plus half times of, what is the derivative of cos x is minus sin x plus cos x. Then yp is equal to x by 2 sin x plus half times of cos x minus sin x. So this is how we got the yp value. So here yp I got as x by 2 sin x plus half times of cos x minus sin x. Therefore, after getting the particular integral, what is the general solution? The general solution is y is equal to yc plus yp. So y, what is yc? Here I'll show you. See here, yc is c1 plus c2x into e power minus x. c1 plus c2x into e power minus x. And what is the yp value here? If you see, this is x by 2 sin x plus half times of cos x minus sin x. This is the final answer. So if I go back to the beginning, so this is the question. You have to identify if x power 1 is there. You have to remember that it is of method 6. So for any problem, I have to find the complementary factor using the auxiliary equation. I got the roots as minus 1 comma minus 1, that those are equal roots. For equal roots, what I have to do? I have to write as c1 plus c2x into e power minus x. To find the particular integral, I have a formula. So what is that formula? It is the formula that is x minus f dash of d by f of d into 1 by f of d into cos x. So f of d is nothing but d square plus 2d plus 1. So what is the derivative for it? That is, it is 2d plus 2. So after substituting d square value as minus 1, I got minus 1 and plus 1 got cancelled. So it is 1 by d. So 1 by d is integration. The integration of cos x is the sin x. So I got the value here like this. Half times of sin x. I'll multiply. After multiplying, that is x by 2 sin x plus 2d plus 2 into d square plus 2d plus 1 into half sin x. After substituting, d square is equal to minus 1. So these are all the things which is very easy. So d means derivative. Before that, I have to do the integration. So 1 by d is nothing but minus cos x. So d is the derivative of this and 1 into cos x. So derivative of cos x is nothing but minus sin x, and I got the particular integral. After getting particular integral, I have to add up the complementary factor and the particular integral. So this is how we got. So this is very easy. When you compare with method 5, method 6 is very easy. So if you don't understand this, at least you concentrate this. So to find this problem, what we have to do? We have to get the auxiliary equation. The auxiliary equation is f of m is equal to 0. So in place of d, I have to write m. So this is m square plus 9 is equal to 0. M square is equal to minus 9. M is equal to root minus 9. So m is equal to, what is this? 3 into 3 into I square. As you all know that I square is equal to minus 1. So m is equal to, what is this? 3i plus or minus 3i. This is a complex root. Therefore, yc is equal to c1 cos 3x plus c2 sin 3x. So how we got c1 cos 3x plus c2 sin 3x? So this is the complementary factor. After getting complementary factor, I'll show you how to find a particular integral. So the particular integral formula is x minus f dash of d by f of d into 1 by f of d into v. So yp is equal to, I'll show what is f of d. F of d is nothing but d square plus 9. F of d is d square plus 9. The derivative of this is 2d into 1 by f of d is d square plus 9. And what is v here? V is nothing but sine 2x. So this is sine 2x. So again I have d square. So what I have to substitute? In place of d square, I have to write minus b square. So what is b? The quotient of x is b. Therefore, d square is equal to minus 4. In place of d square, I will substitute minus 4. Therefore, yp is equal to x minus 2d by d square plus 9. Here, minus 4 plus 9 into sine 2x. So, yp is equal to x minus 2d by d square plus 9 into 1 by 5 sine 2x. So I'll multiply. I'll take this inside, that is x by 5 sine 2x minus 2d by 5 times of d square plus 9 into sine 2x. Again I found d square. In place of d square I have to write minus b square. What is b square? The quotient of x is minus b square. That is 2 square. That is 4. In place of d square again I will substitute minus 4. So yp is equal to x by 5 sine 2x minus 2d of, this is 5 into, in place of d square I have to write minus 4. Minus 4 plus 9 into sine 2x. So yp is equal to x by 5 sine 2x minus 2d, 5 times into 5, 9 minus 4 is 5 into sine 2x. Therefore, yp is equal to x by 5 sine 2x minus 2d by 25 into sine 2x. It is yp is equal to x by 5 sine 2x by minus 2 by 25. There is a continuation here. So yp is equal to x by 5 sine 2x minus 2d by 25 into sine 2x. What is the derivative of sine 2x? I am writing here. Yp is equal to x by 5 sine 2x minus 2 by 25. The derivative is cos 2x. And again for x is equal to 1, 2 will come front. So the answer is yp is equal to x by 5 sine 2x minus 4 by 25 cos 2x. So this is the value. This is the value of the yp. After getting yp, what we have to do? So we have to add up yc plus yp to get the general solution. So the general solution is y is equal to yc plus yp. So y is equal to, what is yp here? If you see, yc is equal to c1 cos 3x plus c2 sin 3x. c1 cos as c1 cos 3x plus c2 sin 3x. Then what is the yp value here? X by 5 sin 2x minus 4 by 25 cos 2x. So this is the final answer. This is how we have to solve using method 6. So it's very easy. If you take the formula and substitute, then it will be very easy to solve. And method 6, if you follow, I hope you all guys understand. And my ultimate purpose of solving and explaining you this all problems is to make your job easier. Please keep watching my video. If you like my video, don't forget to subscribe, like and share it to your friends. Thank you.